What's the driving force behind developing a better, newer method of soil carbon analysis? Current standard analytical methods rely on tiny amounts to determine the amount of carbon. How appropriate is this for the scale of, say, a farm, if you're wanting to determine how much carbon you're sequestering over a large area? With the potential for the agricultural sector to become involved in carbon sequestration, it's important to be able to measure larger amounts of soil that integrate or cover the natural variability of carbon that exists in soil. To do that, we're taking the approach where we are actually extracting and analysing the carbon in the whole core. Introducing the soil carbon bench, a facility to determine carbon from whole cores. The idea is that we actually take cores which can be intact, but it's beneficial to actually break it up and dry it out as much as possible to remove the free moisture. You can analyse half a metre, a third of a metre or a full metre. You can acquire one carbon value per core, or if you like, one carbon value per site. Insert it into the reactor, into the fixed bed reactor, which is sealed up, and we introduce a gas supply which oxidises and also acts as a carrier to transfer the products of the combustion to the analytical system. Now, this is an experimental test bed and it's manually operated at this stage, and we have a furnace, a resistance furnace mounted on wheels. We move the heat to the soil material and thereby break down organic matter within the soil matrix, extracting the carbon and carrying it through to the analytical system. Carbon is extracted from the organic matter in the core and carried through in the gas stream to the detection system, where the signal is recorded on the data system, and the amount of signal we get, or the area of the peak, is proportional to the amount of carbon in the core. Here we have a typical output from core, 50 centimetre core, where we see a signal from atmospheric nitrogen during sample loading, and then we have the signal that's related to the carbon. The area of this peak is proportional to the amount of carbon in the organic matter within the core. We take the areas and input them into a spreadsheet. They form a calibration if we are using known amounts of carbon, or we simply read off how much carbon is in the core based on the function derived from the calibration chart. To put the soil carbon bench in perspective, the standard analytical method allows you to determine a maximum of half a gram, 500 milligrams, very typically this amount. Whereas in the soil carbon bench, we can, by combustion, analyse how much carbon we've got in core material, which is about the mass we're seeing here, 300 to 400 grams worth.